negative number, and I can't take the square root of a negative number, and y has to be greater than or equal to -2. The next problem says write and solve an equation or a system of equations to help you solve the following problem. A cable 84 meters long is cut into 2 pieces so that one piece is 18 meters longer than the other. Find the length of each piece of cable. So I wrote this equation. I know that the first cable plus the second cable, which is x plus 18, has to equal 84. So I got 2x plus 18 equals 84 minus 18. 2x equals 66. So then I know that one of my pieces is going to be 33. So then I do 33 plus 18 equals 51. So I know the lengths are 33 meters and 51 meters. The next problem says Carlo got a pet snake as a birthday present. On his birthday, the baby snake was just 26 centimeters long. He had been watching it closely and I noticed that it had been growing 2 centimeters each week. Create a table. So I know I would start at 0. So that would be when it was 26. And it tells me that it grows 2 centimeters each week. So in week 1, it would be 28. Week 2, it would be 30. Week 3, it would be 32. And so on. So I counted up by, I think I counted by 5s, so that 0.26 would be about right here, and then it's going to just go up like this, approximately. And then my equation is y equals 2x plus 26. That way, at 0, I have 26, but at 1, 2 plus 26, and so on. Then it says if the snake continues to grow at the same rate, when will it be 1 meter or 100 centimeters long? So to do this, I just took my equation and did 2x plus 26 equals 100. And then I solved. Minus 26. So 2x equals 74. Divided it by 2. And I got x equals 37. So it would be at 37 weeks. And then you should have written where you could see it in each representation. So if I took off a point, that's y. So you should have told me that in the table, if I just kept going, I would eventually get to 100 centimeters. If in the equation, I could solve it. And in the graph, same thing. If I just keep going out in my graph, eventually I should get to 100 centimeters. The next problem says, what is the value of y allows you to find the x-intercept? For each of the equations below, find where its graph intersects the x-axis. So you should write each as an ordered pair. This part right here is where most people lost their point. They wrote the correct answer, but did not write it as an ordered pair. So the answer to the first part is what value of y is when y is 0. So a lot of you actually put in when x was 0, and that you found the y-intercept, not the x-intercept. So in A, I would replace y with 0 and get 3x plus 6, subtract 6, and get negative 6 equals 3x. So I get negative 2, so it's negative 2, 0. Plug in 0 for y in this one, so x equals 5 times 0 minus 10. So x is going to equal negative 10. So the correct answer was negative 10, 0. For C, we're going to plug in 0 for y, so 0 equals x squared. Square root is 0. So you take the square root of both sides, so you get 0 equals x. So 0, 0 is our ordered pair. 0 equals 2x squared minus 4. So you add 4 to both sides. 4 equals 2x squared. Take the square root of 4. And this, sorry. Actually, before you do that, we have 4 equals 2x squared, so we divide both sides by 2 first. So 2 equals x squared, so it'd be the square root of 2. So the correct answer would be plus or minus square root of 2, comma 0. So there's actually more than one place that it would cross the x-axis. So then for E, plug in 0. We get 0 equals the square root of, or x minus 5 to the second power. Take the square root of both sides, so you get 0 equals x minus 5, so we add 5. So our ordered pair is 5, 0. And then in the last one, we plug in 0 equals x cubed, negative 13. So we add 13 to both sides. So 13 equals x to the third power. Take the cube root of both sides. So the correct answer is the cube root of 13, 0. That would be our answer. Next problem, it says make a complete graph of the function 2x squared plus 4x minus 6 and describe its domain and range. So I just picked some values for x. So I picked negative 2, negative 1, 0, 1, and 2. At negative 2, it would be negative 6. At negative 1, it would be negative 8. At 0, it would be negative 6. At 1, it would be 0. And at 2, it would be 10. So then I started plotting them, and I figured out at negative 2, 1, 2, 3, 4, 5, 6. Negative 2, 6 is actually right there, and then negative 1, negative 8 would be right here. And then 0, negative 6. Right away in the table I saw that this was where my vertex was going to be, because it started to repeat itself. So my graph should look like that. The domain is negative infinity is less than x, which is less than infinity, or all equal numbers. And the range is y is less than or is greater than or equal to negative 8. The next question is to solve each equation below for the indicated variable. So you had to do some literal equations. So in the first one, y equals mx plus b. First thing I would do is subtract b, so I'm going to get y minus b equals mx, and then I'm going to divide both sides by m. So I get x equals y minus b divided by m. Part b, I need to first divide by pi, and then I get a over pi equals r squared. So I need to take the square root of it. And a lot of people got to this point here, but you forgot the plus or minus. You have to put that plus or minus there. So the plus or minus the square root of a over pi was the correct answer. For c, you're just going to divide both sides by LH. So w is equal to v divided by LH. D was a little trickier. So first you had to get 1 over y by itself by subtracting 2x from both sides. So then we get 1 over y equals 3 minus 2x. Then you had to multiply by y. So you would get 1 equals 3 minus 2x times y. And then you had to divide both sides by 3 minus 2x. So the final answer was y equals 1 over 3 minus 2x. That one was a little tricky. The next problem is we are creating a multi-representational representations for a function. So we have to make an xy table, a graph, and an equation. The function of g of x equals 2 over x. Then make at least 3 summary statements. So I'm not going to write my 3 summary statements. I'll give you guys some ideas. But the equation should have been the easiest part because it was given to you. So then you're going to plug in some numbers. You know that x can't be 0 because I can't divide by 0. So I plugged in 2, 1, negative 2, 4, negative 4. So I get 1 for 2, 1, 2 for when x is 1, negative 2, negative 1, 4, 1/2, and negative 4, negative 1/2. So when I graph it, and I'm just going to sketch it, my graph ended up looking like this. So my summary statements could have been, it doesn't touch 0 in either graph. I could have said that my asymptotes are at x equals 0 and y equals 0. I could have said what the domain was. I could have said what the range was. So you need to make up 3 summary statements for that problem. So problem 93 says, suppose you want to find where the lines y equals 3x plus 15 and y equals 3 minus 3x cross. and you want to be more accurate than your graphing calculator or graph paper will allow. You can use algebra to find the point intersection. So since y equals 3x plus 15 and y equals 3 minus 3x, what must be true about 3x plus 15 and 3 minus 3x when their y values are the same? So the answer is they're equal. They must be equal. So write an equation that does not contain y and solve it for x. So we're going to say 3x plus 15 equals 3 minus 3x. So I'm going to add 3x, add 3x. I get 6x plus 15 equals 3 minus 15. 6x equals negative 12. So divide by 6. So I get x equals negative 2. Then part C says, use your x value found in part C to find the y. So I plug it back in. I'm going to choose to plug it back into the second equation. So I get 3 minus 3 times negative 2, or 3 plus 6, which is 9. And then where do the two lines cross? I just write my ordered pair. So negative 2, 9. So the 94 says the Salami and More Deli sells 5-foot submarine sandwiches for parties. It weighs 8 pounds. Assuming that the weight per foot is constant, what would be the length of a 12-pound sandwich? So we can actually write a proportion for this. So we could do 5 over 8 equals x over 12, and then cross multiply. So you get 8x equals 60, divide by 8. X is going to equal 7.5 feet. 95, if h of x is x squared minus 5, where does the graph of h of x cross the x-axis? Make a sketch of the graph. So I substituted in for 0, so I did x squared minus 5 equals 0. Added 5 to both sides. So I get x squared equals 5. Take the square root. So x is going to cross the x-axis at the positive or negative square root of 5. So we could say the square root of 5 plus or minus comma 0. So if I were to make a graph of this, I would start just by plugging in points. So I figured out that the vertex was at negative 4, 0. Just about right there. And then I just kind of sketched it up because I knew it was going to be a parabola. Problem number 96 says graph the following equations on the same coordinates. So the first thing I need to do is solve for y. So for the first equation, I add 2x. So I get y equals 2x plus 3. And then the second one, I add 3. So y equals x squared plus 3. And then I graphed them because that's what it asked me to do. So at 2x plus 3, I start at positive 3. Which is about right there. And then I'm going to go up 2 over 1, up 2 over 1. Your graph should be much more accurate than mine. And then x squared plus 3 is going to be at positive 3. And then it's going to look like this. So then it says find the x-intercepts for A and for B. For A, the x-intercept is negative 3 over 2, 0. And the x-intercept for B is there is none because the parabola doesn't cross the x-axis. So then the y-intercept would be 0, 3. And it would actually be the same for the other equation because that's where they cross. So where do the two cross? They actually cross at 2 separate points. So I chose to do it algebraically. So I said x squared plus 3 is equal to 2x plus 3. So then I moved everything over, so I got x squared minus 2x equals 0 because the 3's canceled out. So I factored out an x. So I knew that the x values were going to be 0 and 2. Plugged it back in. I chose to plug it into the linear equation. So 0 would give me 3. So I already knew it crossed at 0, 3. Then when I plug back in 2, I get 7. So it crosses at 2, 7. So make sure you had both points that it crossed at. The last problem asks you to match the laws of cosine, laws of sine, the Pythagorean theorem, the quadratic. So I actually matched up the Pythagorean theorem and the quadratic formula first because those two I think are pretty easy to remember. And then I remembered that This one matched to the law of sines, and then this last one is the law of cosine.